Hello and welcome to my channel. In this video we are going to solve an example from graphs, that is equation of straight lines. Now this question has two sub-questions and the second sub-question is divided into three sub-questions again. So let us start with the first one. A is the point 0, 2, B is the point 3, 3 and C is the point 4, 0. Determine if triangle ABC is scalene, isosceles or equilateral. You must show all your working. So here we can see that 3 points are given and the coordinate of each point is also mentioned. So before we begin, let us draw a rough figure for this given points. So here we have the x-axis and the y-axis and the origin 0, 0 and the points A, B, C are marked as follows. Now here we can see that ABC takes the shape of a triangle. So once we have done this, we have to determine whether this triangle is scalene. Scalene means the length of all the sides of the triangle will be different. That is, if AC is 10, AB is going to be 20 for example, and BC is going to be 15. So we can see that the length of all the sides of the triangle are different. So if it is isosceles, then any two sides are going to be same and the third side is going to be different. So for example, AB will be 10 and BC will be 10, but AC will be 15. Or if it is equilateral triangle, then the length of all the sides of this triangle have to be same. That is, if AB is 10, BC is 10 and AC is also 10. So to determine if this triangle is scalene, isosceles or equilateral triangle, we have to make use of the distance formula to find the length of the sides. So let me write the formula here. So the distance formula is given as d, that is the distance, is equal to square root of x1 minus x2 the whole square plus y1 minus y2 the whole square. Now making use of this formula, let us find out the length AB. So here for AB, I have considered the coordinates of A 0, 2 as x1 and y1 and B as x2 and y2. You can use it vice versa as well. That is, you can make 0, 2 as x2, y2 and 3, 3 as x1, y1. It would give you the same answer. So here we have substituted x1 minus x2. So x1 is 0 minus x2 is 3 the whole square plus y1 minus y2. y1 is 2 and y2 is 3. So 2 minus 3 the whole square. So this can be simplified further as 0 minus 3 gives us minus 3 the whole square plus 2 minus 3 gives us negative 1. So negative 1 the whole square. Now negative 3 square is 9 plus negative 1 square is 1. So 9 plus 1 gives us 10. So we get the length of AB as square root of 10 units. Since here whether it is centimeter or meter is not mentioned, we are going to consider it as units. So we have got the length of AB now. Next, let us find out the length of BC. Now when calculating the length of BC, again we are going to make use of the distance formula. Now here my x1, y1 coordinates are taken for B and x2 and y2 coordinates are taken for C. So here we have x1 minus x2, that is 3 minus 4 the whole square plus y1 minus y2, that is 3 minus 0 the whole square. Now we can simplify this further. That is 3 minus 4 gives us negative 1 the whole square plus 3 minus 0 is 3 the whole square. Now minus 1 square is 1 plus 3 square is 9. So 1 plus 9 we again get it as square root of 10 units. Now finally we are going to find out the length of AC using the same distance formula. So let me write here. So here for the AC, x1 and y1 I have considered the coordinates of A and x2 and y2 it is the coordinate of C. So x1 minus x2, that is 0 minus 4 the whole square plus y1 minus y2, that is 2 minus 0 the whole square. So this will be again simplified as 0 minus 4 is minus 4 square plus 2 minus 0 is 2 the whole square. Now minus 4 square is 16 plus 2 square is 4. So 16 plus 4 gives us 20. So this is square root of 20 units. So from this we can understand that the length of AB is same as length of BC, but it is not equal to AC. That means two sides of the triangle are same, that is AB and BC. And we know that if two sides of a triangle are same, then it is going to represent an isosceles triangle. So triangle ABC is isosceles. So let us write here. Since the two sides are equal, that is AB and BC, the triangle is isosceles. Now let us move on to the B sub question. Find the equation of the line AC Give your answer in the form y is equal to mx plus c. So here we have to find out the equation of the straight line AC. So for that, let us consider the coordinates of the points AC and the figure we had drawn in part 1 of this question. So the coordinates of A were given as 0, 2, and here we have considered as x1 and y1. And the coordinates of C were 4, 0, and this is being considered as x2, y2. Now here we have to find out the equation of line AC in the form y is equal to mx plus c, where m represents the gradient or slope of the straight line AC and c represents the y-intercept. So to find out the gradient of the line, we have a formula as gradient, that is represented as m, is equal to y2 minus y1 over x2 minus x1. You can also write it as y1 minus y2 over x1 minus x2. Both the formulae are going to be correct. Now here, since we considered y2 as 0 and y1 as 2, we have substituted the respective values divided by x2 is 4 and x1 is 0. So we have written here 4 minus 0. So this simplifies as 0 minus 2 gives us negative 2 over 4 minus 0 is 4. So 2 and 4 go in the table of 2, that is 2 1 times is 2 and 2 2 times is 4. So we get the gradient of the line as negative 1 over 2. Now once we have got the gradient, let us focus on the y-intercept. Now to find the y-intercept, we have two methods. So if you have drawn the diagram this way, you can clearly see that the y-intercept, that is the line where it cuts the y-axis, is at point 2. So directly we can substitute the value of c as 2. Or the second method is to make use of one of the two coordinates, that is a or c, and substitute them in this equation. So let me show this method as well. So here we have written y is equal to mx plus c, and we have considered the coordinates of a, that is at point 0, 2. Now here simply we have to substitute the values of x, y and m, which we got just now, in this equation to get the value of c. So y value here is 2 is equal to m, we got it as minus 1 over 2, we have substituted over here, times x is 0 in this case, plus c. Now here 2 remains the same, and minus 1 over 2 times 0 gives us 0 plus c. So here we get the value of c as 2. So these are the two methods, that is if you are drawing the figure, rough figure this way, directly you can say that the y-intercept is 2 as the line cuts the y-axis at point 2, or you can use this method of substitution. So finally we have to substitute the value of m and c we have got in y is equal to mx plus c to get the equation of line AC. So let me write here, equation of straight line AC is y is equal to mx plus c. So y is equal to m value, we got it as negative 1 over 2 times x plus c value, we got it as 2. So it's going to be y is equal to minus 1 over 2x plus 2. This is the equation of straight line AC. Now let us move on to the next sub question. Find the equation of the perpendicular bisector of AC. Give your answer in the form y is equal to mx plus c. So here we have to find out the equation of perpendicular bisector of AC. So perpendicular bisector is a line which divides the line AC into two equal halves. So let me just draw it over here. So here you can see a line which has been drawn from the point B towards AC, and this point divides the line AC perpendicularly. So we have drawn a perpendicular angle over here. And this point, let us consider the coordinates as x, y. Now since this perpendicular bisector divides the line AC into two equal halves, this point acts as a midpoint of the line AC. So we have the formula for the midpoint as x, y, that is the point which divides the line AC, is equal to x1 plus x2 over 2, y1 plus y2 over 2. That is the x coordinates added together divided by 2. And the same thing happens with y coordinates, that is add the y coordinates and divided by 2. So here we have considered the coordinates of A as x1, y1 and coordinates of C as x2, y2. So here in this formula, let us substitute their respective values. So we have here x1 plus x2, that is 0 plus 4 over 2, y1 plus y2 is 2 plus 0 over 2. So here 0 plus 4 is 4. So 4 divided by 2 is 2. And 2 plus 0 is 2. So 2 divided by 2 gives us 1. So these are the coordinates of the point which divides the line AC into two equal halves. Now we know that the lines BO and AC are perpendicular to each other. So we have a condition for the gradients of perpendicular lines. As AC and OB are perpendicular to each other, the product of their gradients has to be -1. Now in previous part of this question we had found the gradient of line AC and it was -1/2. And here we need to find out what is the gradient of the line OB. So multiplying the gradients of AC and OB, we should get it equal to -1. So let me write it over here. So -1/2, that is the gradient of AC, times m, that is gradient of OB, is equal to -1. Now here the negative and negative cancels from both the sides of the equal to sign, and 2 goes on the other side and multiplies with 1, giving us the gradient of OB as 2. Now that we have found out the gradient of line OB, let us find its y-intercept, because we need to find out the equation of line OB in the form y is equal to mx plus c. So to find out the value of c, we are going to make use of the coordinate 2, 1, which is on line OB. So let me write here. So taking y is equal to mx plus c at the point 2, 1, here we are going to substitute the value of y as 1, the value of m as 2, and value of x as 2. So here we get 1 is equal to 2 times 2 plus c. So this will simplify as 1 is equal to 2 times 2 gives us 4 plus c. Now taking 4 on the other side of the equal to sign, we get c is equal to 1 minus 4, or finally this simplifies as -3. So the value of c, we got it as -3. So here we have the equation of the perpendicular bisector y is equal to mx plus c. So y is equal to m is 2, so 2x plus c value is -3. So y is equal to 2x minus 3 is the equation of perpendicular bisector. Now let us move on to the last sub question. A, B, C, D is a kite. The point D has coordinates w, 4w plus 1. Find the coordinates of D. So this is an extension now for the triangle ABC. They have made it like a kite ABCD. So let me draw the figure over here. So here we had the triangle ABC. And in part 2 of this question, we had also found out O, which was the midpoint of AC. Now I have extended this line OB, that was the perpendicular bisector, and I have connected it to point D. Now let us first understand the properties of a kite. In a kite, a pair of adjacent sides are always going to be of the same length. So here the length AB was equal to length C, as we had found in part 1 of this question. So similarly, the length of AD will be equal to the length of CD. Now the second property is the diagonals of the kite are always perpendicular to each other. That means the line BD is going to be perpendicular to the line AC. And we had already seen that OB was perpendicular to the line AC. So we have extended OB to the point D. So it looks this way. Now once we have done this, since D is a point which is on the line OB, the gradient of OB will also be equal to the gradient of the line BD. So here the first thing we are going to do is find an equation for the gradient of the line BD. Let me write over here. Gradient of the perpendicular bisector of AC, that is we are talking about BD, is 2. So we know the formula for the gradient. It is m equal to y2 minus y1 over x2 minus x1. So here we are going to consider B as x1 y1 and D as x2 y2. So here in the diagram we have marked the point B as x1 y1 and D as x2 y2. So here we are going to simply substitute the values. So m, that is the gradient of OB or gradient of BD, is 2 is equal to y2 is 4w plus 1 minus y1 is 3 divided by x2, that is w in this case, minus x1 is 3. Now here we can simplify this further. 2 stays the same, the left hand side stays the same, is equal to 4w, 1 minus 3 gives us -2 over the denominator stays the same. Now the next step is we are going to cross multiply, that is w minus 3 multiplies with 2. So we get 2 multiplies with w minus 3 is equal to 4w minus 2. Now let us expand the bracket, that is 2 multiplies with w and 2 multiplies with -3, giving us 2w minus 6 is equal to 4w minus 2. Now let us take the like terms together, that is 4w comes on the left hand side and -6 goes on the right hand side. So we have here 2w minus 4w is equal to -6 becomes +6 minus 2. So 2w minus 4w gives us negative 2w is equal to 6 minus 2 is 4. Or w will be equal to 4 over negative 2. So dividing them together, we get the value of w as negative 2. So we have found out the x coordinate of D, that is negative 2. Now to find the y coordinate, we have to just substitute the value of w as negative 2 in 4w plus 1. So let us do that. So here 4w plus 1, that is the y coordinate, is equal to 4 times, since w value is negative 2, we have substituted over here, plus 1. Now 4 times negative 2 gives us negative 8 plus 1, which simplifies as negative 7. So the x coordinate of D is negative 2 and the y coordinate of D is negative 7. So let us write here, the coordinates of D is negative 2, negative 7. I hope you have understood all the steps and liked the video. And if you found this video useful, then you can click on these playlists where you'll find more examples of these kind. And if you're liking my videos, like, share and subscribe to my channel. And thank you for watching.